Hello everyone, this is your TA Yusuf, and today I'm going to be doing a problem about joint distributions. This is from homework 4, question 7. The problem reads that the random variables x and y have the joint PDF f of xy is given by a constant c when x plus y is less than 1, x is greater than 0, y is greater than 0, or 0 otherwise. Okay, so we need to find the value of the constant c, the probability that x is less than y, and the probability that x plus y is less than 1/2. So this is actually kind of a tricky problem because at first glance you would think, okay, x has the range between 0 and infinity and y has the range between 0 and infinity because they both are greater than 0. But you actually have something different here. You have something called a constraint. And this says that x plus y has to be less than 1. So what does that mean? Okay. The way we want to do this is we want to say, okay, how do I plot x plus y is less than or equal to 1? Well, x plus y less than or equal to 1 can be rewritten as y less than or equal to negative x plus 1. Okay? And what does that line look like? Well, it's a line with intercept b is equal to 1 and slope m is equal to minus 1. So you can start off at b is equal to 1. By the way, this is the y-axis, this is the x-axis. And so look like this, right? Okay? So we know the inequality means that it's less than this, so it's in this region here, below the line. But we also have these other constraints saying that x must be greater than 0, which means that we have a constraint this way, and y must be greater than 0, which means we have a constraint this way. So the only region that our distribution exists is in this triangle over here, okay? In all other regions, the distribution doesn't exist. So, ironically, what we've come to find out is y and x can only take values between 0 and 1, and they depend on each other. So if I were to redraw this, sorry. Okay, if I were to redraw this, we know that it's this triangle-like distribution. And, sorry, this eraser is really annoying to work with. We know this is 1 and this is 1. If I were to choose some point x on this axis here, my value of y is going to be limited by this line, and it's going to end up being negative x plus 1. Okay? So that means if I wanted to find the area in this region, I would integrate x from 0 to x, but I would integrate y from 0 to negative x plus 1, because that's what the constraint tells us to do. So for solving for the constant c, okay, this kind of goes back to what we did with a single variable, right? If I had a one-dimensional distribution that looked like this, and say it was equal to c when a was less than x is less than b and 0 otherwise, what would I do? I would know that between a and b I had the value c, and that area had to equal to 1. Because the total area under the curve for any distribution has to be equal to 1. This is formally written like this. For all values of x and y, the integral under the joint PDF is equal to 1. Okay, so in this case, our joint PDF is pretty simple, right? It's just a constant, c. So integrating shouldn't be the problem. The problem is finding the bounds. Okay? Sorry. So let's do that. Okay? So we know that the integral of c dx dy is going to be equal to 1. Okay? So I'm actually write this as, I think it's better if I write dy dx, where dy, we'll do the dy integral first and the dx integral after. We know that y is going to be limited by 0 to 1 minus x. You can see that above, right? So because of this inequality, we know that y is going to be bounded by negative x plus 1, or 1 minus x, same thing. And then x can take on any value between 0 and 1. So if I were to compute this, I would first have, so the integral of this would be cy 0 to 1 minus x dx, which is equal to 0 to 1, c times 1 minus x dx, correct? And then integrating that, I get c 0 to 1 minus x dx is equal to c times x minus x squared over 2 between 0 and 1. What value does that give me? Let's see. That's going to give me c times 1 minus 1 half, which is equal to 1 half. Okay, 1 half c. And we need that to equal to 1 in order to normalize the distribution, which means that c has to equal 2. Okay, so what does that mean? What does this distribution look like? Well, we know that it's bounded by this triangle here. Okay, I was showing it to you from an xy point of view, but if we were looking at it at a 3D point of view, okay, let's say this is f of x, y. It's y. This is the x-axis. This is the y-axis. Remember, we had this was 1 and this was 1. We had this line, which was where it was bounded, and then we solved for the constant c, and it was 2. So we kind of have this triangular prism kind of distribution where the sum under this curve is going to equal to 1. Okay, so this has a height of 2, and it's bounded by 0 and 1 for both x and y, and it looks like a triangle. And that's the reason that it looks like a triangle is because of this bound that we're given. The x plus y is less than or equal to 1. Alright, so we did part 1 of the problem, and it's going to kind of be tricky because it's not very obvious, but once you get the distribution, the other problem should be very simple. So let's do the next one. So we solved for our distribution, and we said that f of x, y is equal to 2 when x plus y is less than 1, x greater than 0, y greater than 0, and it's equal to 0 otherwise. Now we're trying to find the probability that x is less than or equal to y. And how do we do that? Well, we need to find, we could do that in a few ways, right? You can find the marginal of x. Well, actually, I think the better way to do that is to just plot what x is less than y looks like. Okay? So we had before, we had our little triangle. With value 2. And now we have a new one. We have x is less than or equal to y. And what does that look like? Well, that's y being greater than or equal to x. And this is just a line equation with slope is equal to 1 and b is equal to 0. So that looks like this. And we're greater than it, so we're in this region here. If you use your eyes, you can kind of tell that that's just half of the triangle. So if the integral over the whole triangle is 1, integral over half the triangle is going to be 1 half. So that's kind of something that you can notice right away, but just to give yourself an idea, but we have to show it mathematically. So the idea is if I choose some value of x, okay, what am I going to integrate? Well, we first have this value here from the top line. Okay? Well, that tells me that y's maximum value is 1 minus x. And then we have from the bottom line that x is less than y, so this is going to be x. So I'm actually going to be integrating, okay, from 0 to 1 for x, from x to 1 minus x for y of the same distribution. I know that might have sounded a little confusing because it's not very obvious, but you have two limits, two constraints now. One of your constraints was y must be less than or equal to negative x plus 1. And now the other one is this guy here, x is less than or equal to y, which we rewrote as y is greater than or equal to x. So these are your two constraints. I plotted the two lines for those, and we looked at the shaded region. Now if I choose some point x, I know that y has to go between x and 1 minus x because of these two constraints. Okay? So now we can solve this integral. This is going to be integral from 0 to 1 of 2 times 1 minus x minus 2 times x dx is equal to 0 to 1 of 2 minus 4x dx is equal to 2x minus 2x squared, evaluated from 0 to 1. I actually kind of made a mistake. So if you look here, can x actually go to 1? No, it can't, because that would assume that x exists in this region for this curve. The maximum value of x is given by this point here. And how do I find x max? How do I find that point x? Well, I find that point x by finding the intersection between these two lines here. Okay? So we need a value such that x is equal to minus x plus 1. And if you solve, you get 2x is equal to 1, x is equal to 1/2. So this point here is x is equal to 1/2, and that should actually be my limit. Sorry about that mistake. So I'm just going to... And funny thing is, the reason I knew that was the mistake was because I knew this integral was supposed to go to 1/2, and clearly from the result I had before, that's not where it was going to go. So this gives me 2 times 1/2 minus 2 times 1/4, which is equal to 1/2. Okay? So I guess lesson learned in this is pay attention to your observations that you make before solving the problem, and then compare to what the actual result is, because sometimes you'll find that your eyes are much more trustworthy than your mouth. Okay, cool. So we solved that problem, and now what's left is we need to solve for the probability that x plus y is less than or equal to 1/2. And how do we do this problem? You guessed it. We're adding another constraint. That said, so now we have x plus y is less than or equal to 1/2. So here, y is less than or equal to negative x plus 1/2. Okay? So before, we had x and y, and we had from 1 to 1, just this line here. This is our distribution with value 2 everywhere inside this distribution. And now we have minus x plus 1/2. So now we have we're going to have a straight line with intercept 1/2 and negative x as negative 1 as our slope. So this is going to look something like this. Okay, we need to compute this point, and since we have to be less than it, we're going to be bounded by this region here. What is this point? Okay, so that's the point where y is equal to 0. So 0 is equal to negative x plus 1/2. That's when x is equal to 1/2. So this is x equal to 1/2. Okay, so now this isn't too bad, right? I'm going to choose some point x in this region, and it should correspond to some point y in this region given by this line, which is going to be negative x plus 1/2. Sorry I wrote that like that, but the idea, let me rewrite that actually. Again, I'm losing room. Negative x plus 1/2 And then if this point is x, this point is sorry again. This point here is 1/2 where the lines start, and this point here is negative x plus 1/2. Okay, so now instead my y is going to be going from 0 to negative x plus 1/2, and my x is going to go from 0 to 1. So the probability that x plus y is less than 1/2 is given by x goes from 0 to 1. Oh, I lied again. Does x go from 0 to 1? No. I just showed that earlier. It should go from 0 to 1/2 because that's where the areas, where the shaded region is. And y goes from 0 to 1/2 minus x. And this is of 2 dy dx. Cool. So 0 to 1/2 is going to be 2 times 1/2 minus x dx. Minus 2x dx. Equal to 1/2 minus 1/4, which is equal to 1/2. Okay, so as you'll notice, a lot of these problems are literally just plugging in the constraints that you're given and plotting them and noticing what the value of y is given some value of x. So in some instances, you can actually do it the other way, where instead I choose a value of y and I'm finding a corresponding value of x. But I just like to choose x because x is better than y. Cool. So this is the basic steps to doing these kinds of problems. Remember, always plot your constraints. Over here, it's not so obvious that x and y range between 0 and 1, but it becomes a lot more obvious when you see the picture here. Okay? So I hope this video helped. Please let me know if you have any questions. Come to my office hours. They're Tuesday from 12 p.m. to 2 p.m. Okay? Thanks, guys.